Thanks for coming. Yeah, always good to be here. See some old friends, people in town. South African guy over there, Nick, speaking in an hour or so. Yeah, check out his talk. Okay, so as Mike pointed out, I actually have one small update to my current job situation. We just joined the Amazon folks. So Amazon Web Services currently doing developer relations and taking the Pipeline AI project and integrating it with SageMaker. So if you want to talk about that after, we could talk about it, but yeah, pretty cool stuff. So the Amazon guys have done a really good job with SageMaker over the last couple years. In the beginning, it was a little shaky, but things are picking up. So basically, lots of the pipeline customers were asking about SageMaker and wanting to integrate, so decided to join forces. I have about 106 slides that I need to cover in half the time that I thought I had. Classic problem that I always seem to have. So we're going to cover lots of technologies and tools, and I'm going to give you guys my recommendations for what you should use, or depending on where you're at in your machine learning, the complexity of your pipelines. And also, these slides are all posted. If you go to pipeline.ai, you can click, there's a resources button, and you can get to all the stuff that's going on there. Okay, so quick background, Netflix, Databricks, paid my dues there, moved to the Bay Area about 10 years ago. Also have this meetup in this area, which some of you might have found out about this conference because of the meetup. It's called the Advanced Kubeflow meetup. It used to be the Advanced Spark and TensorFlow meetup, is now Advanced Kubeflow. And I'll explain that here in a bit. So here's the meetup. Got about 12,000 members. We've been around for about 4.5 years. Hundreds of videos all across the globe. Lots of different talks. 4.5 years in technology terms is a lot of technologies and a lot of shift. There's a free upcoming workshop, actually, for you guys, thanks to Amazon. That was one of the reasons also I wanted to join forces, was I get access now to lots of compute. And lots of EKS clusters, Elastic Kubernetes clusters, and we'll be installing Kubeflow and getting all this running. So basically, it's the 8-hour version of what I'll be showing you guys today in 30 minutes. So sign up for that. Go to workshop.pipeline.ai. It's free. It's my little holiday gift to you all. Okay, just out of curiosity, who here is okay with command line? Python? How about Docker? Mostly, okay, some alternate. Yeah, hopefully if you're command line, you're also Docker. Yeah, how about Jupyter Notebooks? Okay, statistics? Oh, yeah, fuck yeah. All right. Start off with a little joke here. That's not a joke, it's actually real life. While going for funding over the last couple years, we ran into this quite a bit where these VCs would ask, how many GitHub stars does your project have? I would say, X number. And they would say, okay, we can give you Y in seed funding. And all the numbers ended up being about $1,500 per GitHub star. It just always seemed to work that way. It didn't seem to be, from our perspective, that's what it was. So please start this repo, and then maybe when I'm done with my Amazon tenure, we can go back and get some funding again. Okay, don't look at this just yet, because I'll be doing that for the demo, but I'm going to show you that link at the very end. So the context here, and as I've gotten older and wiser and gray hair and hair on my ear. Yeah, I don't know if you guys start to get hair in weird places, but I've started to pay more attention to what I'm actually doing and what's the business value of what I'm working on. I used to do and focus on tools, and I would geek out, and I'd spend all the weekends getting GPUs running, and I would end up Monday morning, and I would have basically nothing from like any business value. So I do want to talk about some of the kind of higher level problems that we're trying to solve here. And this is kind of a depressing slide, but just know that when you push your model into production, it is already out of date. It most likely has bias, number two, based on how you've collected your data, right? Depending on how you've collected your data, how you've normalized your data, how you've sampled your data during model training. Your model is likely broken, or could very likely be broken. You will notice it more when it's broken than when it's not broken. So it always seems like it is. This could be blowing the heap. This could be we haven't provisioned like enough resources in your Lambda functions or your EKS containers or Docker containers. Your model will instantly start getting hacked. The second that you can pass an input and look at the output, you can reverse engineer and learn that model. This is made worse because we're all using the same models, right? We've all been told over the last couple of years, don't like reinvent the wheel. Grab somebody else's model. Take a model from Google. Take BERT. Take Riley ImageNet. The problem with that is these models are public, and all the weights are known, the architecture is known, and very easy to back into. So we'll have a couple slides at the very end, 3 or 4 slides, and a notebook at the very end talking about data privacy, and specifically with respect to machine learning and how to train your models with something called differential privacy, which sounds as scary as it is if you start looking at the math. Also, your models are probably slow. They could always be faster. You're probably not paying attention to the hardware, or you haven't gotten around to paying attention to the hardware that you're deploying on. There's lots of different hardware-specific optimizations. So the concept here is called hyperparameter tuning. You can actually hyperparameter tune on your models after, they've been trained. There's certain runtime characteristics that you could try out that are specific to the hardware that you're deploying to. If it's GPUs is the most obvious, if it's small devices. So we have a couple slides and a notebook or two on post-training optimizations to make your models faster. All right, so a lot of these slides are actually from the workshop, so just kind of ignore some of the setup stuff. But at a high level, this is what we'll be doing. We have a Kubernetes cluster, so during the workshop, everyone gets their own. We're going to use TFX. TensorFlow Extended is actually what Google had in mind with TensorFlow, but they didn't really tell us this. They've been using something called TFX internally for many, many years within Google. They've just been slowly sort of open sourcing pieces. So the first piece, of course, was TensorFlow Core. The second piece was actually TensorFlow Serving, which is part of the larger ecosystem, the ability to take your trained model and deploy it. Then about 2 years ago, or about a year and a half ago, they released these models called TensorFlow Data Validation, TensorFlow Model Validation, and these were just kind of Python libraries. There was this project called Facets that could visualize and show your models after they've been trained. You can kind of slice and dice. All of this was really part of TFX, but they were just kind of slow to show us the whole picture. So this has become, and so this is literally pip install like TFX. Okay. We'll also talk about, I'll show an Airflow pipeline. I'm sure quite a lot of us are using Airflow. Well, if you're in Scala land, probably not, but if you're in Python land, you probably are. We'll also show Kubeflow. We'll show how to do hyperparameter tuning with Kubeflow. We'll also talk about MLflow, which I think is on the next slide. But this number 5 bullet point is probably my favorite, which is taking a notebook and deploying it onto a cluster. So my time at Databricks, I didn't really get why this was such a big deal, but it's a huge deal. The ability to take, for example, the Databricks Spark notebook and have that run as a job on a cluster is the whole reason Databricks exists, right? And that feature took about probably 2 years to stabilize, right? They had to build their own notebook. They had to build their own scheduler. It's actually not using Mesos. It's not using Kubernetes. And yeah, lots goes on. So fast forward, 3 or 4 years, we're finally just now starting to see the ability with Kubeflow and with things like MLflow to actually deploy a notebook onto a cluster and then run a job. And then we'll also cover MLflow, Papermill. Yeah, who here has heard of Papermill? Okay. Yeah, so Papermill is pretty cool. You could pass in a Jupyter notebook as a parameter, or as an input, pass in parameters, and then run that notebook as a cron job. Okay, so like Netflix uses Papermill pretty heavily. I mentioned TensorFlow Privacy, which is a first-class project off of TensorFlow root. Like GitHub, this is using differential privacy. We'll also hopefully have time for the model serving and some quick A/B testing. I got it set up so I could just run through and just kind of show you guys. And then if you want to offline, you could do it on your own. And then model optimization. This is taking a model, quantizing it down, making it smaller so that the actual inference, the actual predictions run much quicker. All right, let's skip through these. Why TFX? Why Kubeflow? So let me set up a little bit more context here. I've specified 6, 7 different systems here, zero index, of course. These systems are really the whole pipeline, right? And this is one way to look at it. And I sort of separate out each system, sort of it's basically by the hardware that is needed for each system. System 0, not a lot of people think about this system. It's called Feature Store. There's more advanced shops are actually building Feature Store. There's a couple startups up in San Francisco or across San Francisco to the west that are focused on Feature Store. It's really when you start getting beyond just converting string or floats into ints or doing small time feature engineering, but actually creating word embeddings and complex features and the ability to share these across different teams. So the sort of common machine learning user probably doesn't even think about this, or they're just storing them on disk somewhere, and then sending a Slack message to some other team to point to that same directory. But Feature Store is a much larger project, much larger system. So keep that in mind. There's not a whole lot out there. There's a couple meetups that have covered it. There's a project out of Pinterest that's focused on it, I believe. I think the Airbnb folks have a project that they might open source also. System 1 is, this sort of broader data ingest. This is trying to get CSVs and then converting them in to Parquet, something like that, Avro. There's the second one, so there's data ingest, and then there's analyze your data. And that's really where TFX comes in, is that you could take a look at all of your data as it's coming in. You can stream through all the data, the details. They use Apache Beam, which is a big mystery to all of us, except for people at Google, and can actually extract out the schema, can look for any anomalies, can tell you if there's certain features that are just missing in this current batch of data that you're pulling in. This happens all the time. When you're scraping application logs, you're very dependent on upstream, what's happening with these application teams. You then do data transformation. This is all classic ETL. And then TFX also helps with data validation, so the DV. So data analysis, which is kind of looking at the raw features, transforming, and then doing data validation. System 6 is kind of a cross-cutting. I didn't want to forget it. It is a pretty major system. That's really where SageMaker and a lot of these folks come in. System 2 is more ad hoc. So this is your Jupyter notebook. This is where, a lot of us tend to end. System 3 is really, training the model, validating the model, getting a little bit more complex. If you think of a concentric, Russian doll thing is what I always say. Think of it as getting broader and broader, larger and larger hardware. System 4, this is where you're doing the full distributed training on all the machines that you have, doing hyperparameter tuning. System 5, we're pushing the model out, we're doing A/B testing, and that's the full pipeline. And of course, we're learning from the model in production, and the flywheel continues. So the whole idea is that we can detect bad features coming in. So if you think of it like a funnel, classic funnel, where we are always trying to stop this pipeline for some reason. The funnel gets more and more narrow. There's more and more reasons, so we should get more and more confident as we get through these systems. So we might kill the pipeline because the data's bad, or we're not expecting it, or it's violating some schema. We may have bad hyperparameters, things aren't converging. So there's lots of different reasons before we're actually going to put the model into production. And so TFX helps with this. Kubeflow helps you automate it. This will help you stop early. And lots of other stuff on the left there. Composability. So Kubeflow really most enterprises right now seem to be very excited about Kubeflow because they either just have SageMaker, they just have Azure ML, they just have Google Cloud ML, they don't want lock-in, they want the safety to build pipelines and then be able to port those pipelines from one cloud provider to another to on-prem. And so Kubeflow opens that up, which is why I'm excited to work on Kubeflow at Amazon. So here's TFX. If you think of TFX as a set of libraries, you're not too far off. It's just Python libraries. It's also kind of a reference set of components that you could use to build your pipelines. So there's a little, there's kind of a mapping between these two, but yeah, so let's just focus on this one here. But there's feature load, feature analyze, feature transform, model train, model evaluate, and then model deploy. So it's all pretty much the same as the previous one. The names here, those things that are in orange, are physically the out-of-box TFX components that you can use to build this pipeline. Those tabs up on top show that you could actually use TFX with Airflow. It's just Python libraries. You could use TFX with Kubeflow. And I've even seen people use TFX and build these ML pipelines with Jenkins, right? Some very large machine learning shops that really all they needed was to have, something, like some component take an action, there's inputs, outputs, and then some, like future downstream component be able to pick up the output from the previous one. So yeah, Jenkins works okay. People are moving to Kubeflow because it is a set of standards. Also note that you don't need to use TFX with Kubeflow. You could completely use TFX on your own. You would kind of have to coordinate things on your own. You could also use Kubeflow without TFX. I would recommend starting with the simplest thing you can and just add things in as you need them. Most shops don't really need, at least straight out of the box, they don't really need to be doing, the constant skew detection. They probably should be doing more bias detection, but if you're just starting off just trying to get a model trained, don't start here. But like just to give you guys the sort of lay of the land, so the example gen, that term gen is it's a Python thing, generator. So the example gen, when you talk about machine learning, that term example does not mean what you think it means. It means like a row of training data. Sample, right, like example. I've had multiple conversations with people where I'm talking about a row of training data and they're talking about a sample piece of code, and it's not the same thing. And somehow we ended up talking for like 5 or 10 minutes. So there's statistics gen. This is actually capturing all of the statistics, standard deviation, norms, all that stuff, and by taking one big pass, right, like using Apache Beam, for all the features in your data set. We're then validating those features. The schema generation is super important. We can use that schema later on. So it's very important to get that right. If you're familiar with Spark, Spark actually has very good schema generation also. Can take CSVs that are all over the place and then try to make sense of it. So training is probably the simplest part of this whole pipeline. And then we're going to validate the model, which you can sort of out of the box just have it pass through or just do some simple cursory checks. Is this model 1% better in terms of F1 score than the previous? Then pass it along and then push it into production. I've seen people actually use Slack for the model validator, where they will suggest that a model is good or not and post a message to Slack and have the team actually click through and then validate the model manually and then push it into production with /yes or /deploy, something like that, /commands. All right, so this is Airflow implementing those same components. And this is super easy to get working out of the box. Yeah, we have the community edition for pipeline, which is free, so you can go out there and check that out. And then here's a similar pipeline with slightly different names. This is how you do it in Kubeflow. This is what it looks like. I'll show you guys the code here in a sec. The other one, I haven't talked about this too much, but this is MLflow. If if I were you and starting completely from scratch, and I do not have any like Databricks options or anything like that, so I have no interest in this project succeeding or not succeeding in any way, like financially. It's a really good project. It's very, very simple. It does exactly what you want it to do, which is track an experiment, train your model, like capture those hyperparameters, and then capture the metrics and post them to some single tracking server. So very powerful, has really good visualizations out of the box, very simple Python API, supports Scala, supports Spark, Java, and R. Supports TensorFlow, scikit-learn, Keras, all the big ones, PyTorch, all that stuff. So check out, MLflow. I have a couple notebooks on it that we'll skim through here in a bit. Hyperparameter tuning, this is actually a slightly older UI from a slightly older version of Kubeflow. It's been updated a little bit, but this was pulled from a project called ModelDB that came out of MIT. That project got a little crusty, got a little long in the tooth, got some hair on its ear too as well, I think. And so here, what we're doing is showing this nice UI, or like somewhat nice UI, that will let me actually generate the YAML that's needed to run on my Kubernetes cluster. So I jumped ahead a little bit, but just know that you can, with one click or one change in your configuration, change your hyperparameter tuning strategy. And supports all the big ones, hyperband, Bayesian optimization, and random search, grid search. So this is all part of the Kubeflow umbrella. This project was pulled out of ModelDB, basically copied and pasted into this project called Katib, which is a first-class project off of Kubeflow GitHub root. For the traffic routing, we're using something called Istio. It's the Kubernetes conference next week, so this will be, I think, third or fourth year for this conference. And this project gets more and more talks each and every time I go. It uses something called Envoy, which is by the Lyft folks. So there should be lots of credit going to the Lyft people. It's a way to route traffic. So from a machine learning standpoint or microservice standpoint, you want to deploy your model and point 5% traffic or mirror traffic to a canary version of your model. So it does traffic routing, takes care of all that. So with just one little change to your configuration, you can point 10%, 15%. You could trigger off of some header that's in the HTTP header and send to a completely different cluster. Yes, all that stuff's right now, the state of Kubeflow and Istio and Kubernetes, you're really doing a lot of this sort of manual editing yourself of these configuration files. There's tooling that's been coming along under Kubeflow that helps out. All right, I think I'm going to skip the internals of TFX. I do want to highlight this. This is data validation. This is what's actually looking if there's a high number of zeros, if there's certain features whose scale is much, much larger than other features, then those features need to be standardized, normalized, so that they don't dominate during the training process. Let's see, we're also looking at distributions. Here, okay, TFT, this is pretty basic stuff. All of these TFX components, you are pretty much always going in and then customizing some function, the sort of template pattern kind of thing. All right, I'm going to skip ahead here. Yeah, how much time do I have? 6 minutes, okay. Saw you getting ready to give me the 5-minute. Here's the model analysis. So this is very important. So you do need TFX for this. You would use Airflow and Kubeflow to automate the process here, but you have to use TFX and specifically model analysis library that plugs into your Jupyter notebook and shows you the distribution across different slices of your data. So this is how you would sort of visually detect bias. So you'd see certain parts of your data set are more represented than others. If this was gender and age, this is bad if it's not even. This is actually the Chicago taxi data set, trip data set. So there's certain times of day where this model is more confident, more accurate. These are things we have to keep an eye on. Another topic is metadata. So in the upper right, as we show all those components, all of these things have to store data. to be picked up by the next component. This is all stuff we built probably multiple times over the last 15, 20 years, whatever, but yeah, just know that all this stuff comes around again. Kubeflow is trying to tackle this problem as well, and TFX has some opinions on how to store that data. All right, let me jump into some hands-on stuff here. So this is what Kubeflow looks like. We have 5 minutes, right? Okay. Okay, 10 minutes. Yeah, so lucky you guys. You get me. Okay, Jupyter Notebooks. We have Airflow pipelines, Kubeflow pipelines, the MLflow pipelines. So we've made some modifications because some of these projects like Airflow and like MLflow are actually not part of Kubeflow, but they do have Kubernetes versions, and because Kubeflow is all Kubernetes native, very easy to deploy. This is TensorFlow distributed. So yeah, let me just kind of go through here. This is our actual Kubernetes cluster right now. This is what it looks like. We have Airflow running, the central dashboard. These are pods that are running inside of this cluster. These are basically Docker containers. Okay, that's like what the 1/1 is. It means one Docker container is ready out of one possible container. Kubernetes is handling all of this resource allocation. And the actual notebook is this. It's this community-0. So, and there's a lot of other stuff. Here's a pipeline that I just ran, and I think somebody else is probably running right now. This is the hyperparameter stuff that's backing all those different strategies like random search, grid search. And here I'm going to describe this pod. So this is a Kubernetes command line thing here. The first thing you should do when you describe something in Kubernetes land is search for the word image. Because Kubeflow is Kubernetes native, that also means it's Docker native. And it means there's a Docker image that's running somewhere that's powering this Jupyter notebook. And so here it is. We've actually built one with a bunch of like TFX libraries pre-installed, everything. First thing you should do. So if you're handed a Kubernetes cluster just out of nowhere, that's the first thing you should do. The second thing you could do is do kubectl logs. If you're familiar with Docker, which a couple of you were, you could actually go in, and some of this should look familiar. This is what the Jupyter notebook is logging when you run it locally, except now it's running it inside this cluster, and it follows the same like commands like Docker logs, kubectl logs. All right, so that's the cluster. Here's some of the TFX stuff. I think I'm going to skip over this, just get to more of the visually interesting stuff. All right, and here is Airflow. So this is live. This is actually, this is the Airflow. These are each of the components here. We can go look at the code. Click on code. This is one big Python file. Now, so it doesn't have to be, but just kind of how it ended up. It's using TFX libraries. So if you're familiar with Airflow, it basically has its own library that you could set up these graphs of execution, and they end up looking like this here. If I click on the graph. So that one single Python file has built this, and now we can go through and just keep running this. We could fail if any of these fails. We could fail the pipeline. We can notify people. Has Kubernetes support, S3 support, Google Cloud Storage, all that. All right, let me show you guys the equivalent on the Kubeflow side. It was this first one. So here's a run. So this is live. This was, if I click into each of these here, I should be able, so each of these components, like I said, so Kubeflow is Kubernetes native. It's its biggest strength and its biggest weakness, in my opinion, right? Depending on who you are. It's a strength for the ops folks in the room. It's a weakness for the machine learning people in the room, because we always have to think about Docker images, right? Versus just Python snippets of code. So I'm clicking on this. This one node or like component in this Kubeflow pipeline is a Kubeflow pod, and therefore a Docker image was created. Here's the inputs, here's the logs. This is actually, if you did kubectl logs on this pod, this is what you would see. And the other cool thing is that you could build these like custom artifacts or like custom like viewers of like different artifacts. I keep pulling up the wrong one here. So this is a training node. I'm actually training this deep neural network. I could actually spin up, yes, I could spin up TensorBoard here and then view it directly within the UI here, which is kind of cool. I could also take a look at, here's the ROC curve, here's confusion matrix, supports only binary right now, and lots of other cool things. So this is kind of the groundwork for like more and more visualizations. The other thing is I could actually compare these runs. So right before the talk, I ran 2 runs, and here I could see these metrics. Now, Kubeflow right now, to me, is not the best tool to run these jobs and then compare these metrics. It's a little bit weak. It's getting better. I actually like the MLflow stuff. So this is really the best I could do here. I could kind of highlight 2 runs and then sort of, you know, I could sort, I think, over here. Okay, maybe not. Cannot sort by that column, so that's not even good. But I could just sort of side by side look at these like parameters being passed in. Let me show you guys MLflow. Oh, and then here's the hyperparameter stuff here. So I'll talk about that in a sec if I have time. MLflow. So the code here, it's super lightweight. Let me show you. Yes, all it is an import for the MLflow. So you do pip and then install MLflow. This is a scikit-learn model, and yeah, MLflow has native support for scikit-learn. I define my tracking server. Because this is on a cluster with a shared file system, I'm actually taking advantage of that. All these pods, including my notebook, can access the same shared file system. I'm not going to go over the wire or anything like that. I'm just going to dump it into the file system. Create the experiments. That's just a logical grouping of these runs, and then just do my normal thing. And then here I'm using a Python context manager with something. So all the statements that are indented will now run within that context of the MLflow start run. Here I'm like logging the hyperparameters that are used for this run. I'm logging the metrics that are used. And they end up showing up nice and clean over here. And I could compare. I could also do parallel coordinate plot, which are some of my favorites. So if I'm trying to optimize, if I'm trying to find the best hyperparameters and trying to optimize root mean squared error or something like that, I could plot all these and then back into the best hyperparameters. Okay. I think. Here's Papermill. So here's where I'm actually passing in a Jupyter notebook as an input, passing parameters. I'm saying, take that notebook and run it, and slam in the values 0.6 and 0.1 for these 2 parameters. It will actually render that like notebook and then save it out. If you do any visualizations, if you're doing Matplotlib or Seaborn, those notebooks actually get rendered and you can inspect them later. So let's take a look at one of the ones that was rendered. 2 minutes? Okay. And yeah, so these values were actually slammed in place and take over. It's a super simple project. It's used heavily by Netflix. It's pretty powerful. Okay, I do want to end, I think, on the privacy stuff. I think personally is probably the most interesting. So let me get to that. So TensorFlow has this thing called or it's a library called TensorFlow Privacy. It's using differential privacy beneath the covers. So, right, like what's happening here is we are adding noise, right, like during the actual training process to mask each individual row. That's kind of the high level. So what we're doing is, if you have the patterns, you're still able to capture the patterns of your data, but not able to get back to specific rows in that data set. So of course this is very important for polls and voting, and if you release a model and now you can pass in a person's name and see their vote, if you have super high confidence, if it's 95% confident that vote is yes or Trump or Hillary, whatever, that's not good, because that means that the model has likely seen that data, okay? So it's a little bit counterintuitive because, right, like we always want high confidence with our predictions, but we don't want too high confidence, because then it's very easy to hack that model and then back into. So think of it kind of like blurring the input data. Yeah, and so there's obviously trade-offs. Sorry, yeah, this came out of, there was the TensorFlow World, I think 1 or 2 weeks ago, and I was taking screenshots as fast as I could so I can capture this. But there are trade-offs, of course, with accuracy, but, and so like differential privacy has this concept called a privacy budget. Okay, it's time. You choose the budget that you're willing to allocate to privacy. The trade-off, of course, is accuracy. You could also use privacy to help with explainability also, because you're kind of this like rising tide of confidence. Okay, so check out TF Privacy and a project called KF Serving, like Kubeflow Serving. Also, like lots of good integration with Grafana, Prometheus, and then there's a model optimization. So I'll end it. There's the link for Community Edition, so that's actually what I'm running on right now, if you guys want to go check it out. And then, yeah, thank you. Hope to see you guys December 20th online.